In this video, I'm performing partial fraction decomposition involving a repeated linear factor using the method of comparing coefficients. In this example, I'm going to rewrite x plus 1 over x minus 1 squared, x plus 2 as partial fractions. So the first step is to assume the partial fraction form. So we can use our table of partial fractions. And so because we have this repeated linear term, x minus 1 squared, this gives us a over x minus 1 plus b over x minus 1 squared. So we have to include the squared, but also all of the lower powers of that factor. And we also have for the x plus 2, this gives us plus c over x plus 2. The next step is to multiply everything by that left-hand side denominator. So multiplying through by the x minus 1 squared, x plus 2, and we can cancel out any terms. So on the left hand side we can cancel out the denominator. With the a term we can only cancel one of the x minus 1's. With the b term we can cancel the x minus 1 squared, and with the c term we can cancel the x plus 2. So this leaves us with x plus 1 is equal to a times x minus 1 x plus 2 plus b times x plus 2 plus c times x minus 1 squared. So expanding out the brackets and collecting the like terms, this gives us that x plus 1 is equal to x squared times a plus c plus x times a plus b minus 2c plus minus 2a plus 2b plus c. From here we can compare the coefficients in the equation to get some simultaneous equations. So the first equation comes from comparing the coefficients of the x squareds. On the left hand side there's no x squared, so the coefficient is 0. And this is equal to the coefficient of the x squared on the right hand side, which is a plus c. So this gives us 0 equals a plus c. Comparing the coefficients of the x's, this gives us 1 is equal to a plus b minus 2c. And then the final equation comes from comparing the numbers. So on the left hand side we have 1, and on the right hand side we have minus 2a plus 2b plus c. So we can solve this system of simultaneous equations using any method that you know. So taking that first equation, 0 equals a plus c, I can rearrange this to get the substitution a equals minus c. And then in the next two equations, I can replace the a with minus c's. So since the last two equations have both got 3c, the second one having minus 3c and the last one plus 3c, if I add these together, this gives me 2 is equal to 3b. So dividing by the 3, I get b is equal to 2/3. From here, I can substitute this into the equation 1 equals b minus 3c. And solving this gives me c is equal to minus 1 over 9. And then I can substitute this value for c into the equation a equals minus c. And this gives me that a is equal to 1/9. Having found the values for a, b and c, I can now put these back into the assumed partial fraction form. This gives me x plus 1 over x minus 1 squared, x plus 2 is equal to 1/9 over x minus 1 plus 2 over 3 over x minus 1 squared minus 1/9 over x plus 2.